Okay, so when you look at the board, I've actually tried to translate the sodium symbol, which is Na. It's a sodium metal, okay? And then chlorine, this is a liquid, okay? And then when you look at the product that is being formed, this is called sodium chloride, okay? Now, there is a pattern that you must be able to understand how a compound is actually formed. And when you look at the name is not different from any of the individual elements, okay? Except that there is just a bit of a change that we see on the non-metal part, okay? Now, with that said, in chemistry, these are the basic and very big fundamentals that you have to understand. Because if you don't understand them, it's going to actually become very difficult for you to understand some of the bigger topics that you're going to face along the syllabus. But I wish to say that we have to understand that sodium, which one of these is a metal, which one of these is a non-metal. Okay, so because obviously when we get copper and sodium, these two elements, which are solid in nature, cannot actually give us anything, okay? Because there is no power to combine, okay? Even if we use some catalysts to combine them or we force them, but nothing, is going to actually properly be formed. And we see that most of the chemical reaction that occurs must be in two different state of matter, okay? So liquid, solid, gas, and aqueous form must be able to understand that. Okay, now when you look at chlorine, is found in group 7 of the periodic table. So most of the elements that are found in group 7 of the periodic table, they are referred to as maybe gases or halogen, okay? But more especially non-metals, okay? And then the sodium is found in group 1 of the periodic table. So if you've got the periodic table with you, you will discover that just the first column of that periodic table contains sodium. Now, what is it that you need also to understand, okay? Now, I've just erased the last part of the product. Now, why am I doing that, okay? Now, the thing that you want to understand is that how is that product formed? Okay, the sodium chloride that I wrote, okay? How does that come about, okay? Now, one of the most significant thing and important thing that you have to understand is that this sodium is in group 1, and then also chlorine is in group 7, okay? Chlorine is in group 7. So, now, the secret is that when two elements, okay, combine together, okay, the idea is that it's not about forming whatever that they're forming, okay? It's about that compound that is formed, okay, at the end of the day needs to be a stable compound, okay? So the major essence about chemical reaction, okay, that we see in chemical equation that are taking place is that the compound that is formed must be a stable compound. Because if it's not stable, then you are going to have a challenge, you're going to have a problem there. So now, when you have sodium, since it is in group 1, then we expect that only one electron, okay, one electron of sodium in the outermost shell, okay, is going to actually participate in that chemical reaction or in that chemical equation, okay. So this one, okay, and then also, okay, and then also this chlorine, okay. Now that chlorine, we understand that chlorine is in group 7 of the periodic table, which means that if any element, okay, in the if any element as is in group 5, okay, and going upward, okay, to find how many electrons, okay, that are going to participate in that chemical reaction is that we need to subtract the maximum number of electrons that the atom could possibly obviously have, which is 8, okay, and that's the reason why we've got 8 groups from the periodic table, okay. So since now chlorine is in group 7, okay, so for us to find the number of electrons that are going to participate in that chemical reaction is that we need to subtract, okay, 8 minus 7 to get or to understand how many electrons in the outermost shell are needed for this chlorine to either share or actually gain or actually lose the electron. Okay, so we understand that 8 minus 7 we get 1. Okay, so this tells you now to say that when you are talking about even hydrogen, okay, hydrogen is never specifically put in any group on the periodic table, and the reason is simple, because most of the time when hydrogen is behaving as a gas, it is in group 7 of the periodic table. When hydrogen is behaving as a metal, it is normally in group 1 of the periodic table. So chlorine, if obviously sodium is a metal, chlorine is going to actually be a non-metal, and obviously an halogen. Okay, so we have 1 there. Okay, now you have to understand one thing, that is that if the element you're dealing with, okay, was in group 1, 2, 3, and 4, so the number of electrons, okay, that are going to participate in that chemical reaction is equivalent to the same group number. Okay, so if you are talking about, for example, calcium is in group 2, so meaning the number of electrons that are going to participate in the chemical reaction is 2. If you are talking about nitrogen, let's say for example it is, if you are talking about, I would say aluminium, it is in group 3 of the periodic table, so meaning the number of electrons for aluminium as a metal is going to be 3, okay? But the moment you just reach 5, okay, so to find the number of electrons that are going to participate in a chemical reaction, you have to subtract that number from the total number of electrons in the outermost shell, which is 8, okay? So that's what we have just done, okay? So chlorine is in group 7, so for us to find how many electrons are going to participate in that chemical reaction, we say 8 minus 7, and then we get 1, okay? So when 2 elements are in this form, they are going actually to exchange these, what we normally call the valences, okay? So this is going to come to sodium, and then this is going to go to chlorine. Now, if those numbers that we are looking at are normally just a coefficient number like 1, then there is no need for you to specifically show the ones, okay, unless you're talking about 2, 3, 4, and just like that, okay. But if the numbers which were involved as in terms of exchanging, when they combine, when they're forming a compound, there is no need for you to actually show those ones, okay. And that is the more reason why at the end of the day we have just sodium and the chlorine combined. Okay, so since the numbers that have actually swapped or exchanged are just ones, okay, so there's no need for you to actually specifically show or indicate those ones, okay. Now, that's what you really actually need to understand about chemical reaction or chemical equation. But much more of that is that this arrow actually is normally, points you to what is formed, or normally in the mathematical sense, this is just simply an equal sign, okay, in the mathematical sense. So before this equal sign, okay, before this equal sign, So whatever is before this equal sign is these are reactants, okay? These are called reactants. And then whatever is after the arrow, the forward arrow, or in mathematical sense, after the equal sign, whatever is going to be there is what you normally call the products. Okay, so the products, that's what you call after the equal sign. Okay, so this is an intro to how you can really understand how to balance chemical equation or chemical reaction. Okay, so I hope if you're still behind, you can still actually inbox me, and obviously I'll be able to get back to you. And for those who are watching for the first time, this is a Radical Academy, and my name is Mike Wada. And please support us, okay? Support us by subscribing to our channel and also liking our channel, so that whenever we do post videos like this one, you'll be the first person actually to see these kind of videos of this video. You'll be the very first person to see them, okay? So it's bye bye. I'll see you in the next part of the video, and stay blessed. Thank you.